Good day to all. Welcome to the third tutorial lecture on electrostatics. So, the third problem which we are going to see is button problem. The problem is the charge is distributed along the z-axis from z is equal to minus 5 to minus infinity and z is equal to plus 5 to plus infinity with a charge density of 20 nanocoulomb per meter. Find the electric field E at 2, 0, 0 meter. Also express the answer in cylindrical coordinates. This is the problem given. So what you have to do is, the problem given is from minus 5 to minus infinity and plus 5 to plus infinity. The charge density given is 20 nanocoulomb per meter. So you can notice this charge distribution is given in coulomb per meter. So we can conclude that this particular charge density is line charge density. So since this is going to be line charge density from 5 to infinity and minus 5 to minus infinity. These are all the two charge distributions given, but the two charge distributions having same amount of charge density. But in our theory discussion, we had only one charge distribution. Due to that particular charge distribution, we are finding out the electric field on the point called x, y, z. That is the only thing we have found, derived in the previous theory lecture. We are going to apply that particular formula itself, because that formula only having the cylindrical representation of that particular electric field intensity. So we are going to apply this particular formula in our problem also, but the problem is we can find out only one due to the only one charge distribution only. We cannot find out the second one. So we have to take the segments. First segment is 5 to infinity. Second segment is minus 5 to minus infinity. So how to find out the particular electric field is, we have this formula. We know what is this alpha 1 alpha 2 over this particular formula, because if you know that particular terms, then only you can apply that particular formula. So in order to find out how to evaluate those kind of angular parameters, we need to find out this particular diagram. So here you have the charge distribution A to B. You having the angular distance of the A on the projection of that particular point is alpha 1. Projection of second point on the projection is the angle from the point B, the second edge, to the charge density is alpha 2, and the vector r vector, the projection of the angle of z to the particular r vector is going to be alpha. This and all we know. You have to take this kind of representation on your diagram also. Here you notice you are having 5 to infinity and the minus 5 to infinity charge densities are drawn. You have to draw the vector lines, the projection lines from the two ends of the charge densities. So you are drawing to the point on the x-axis, because we have been asked to find out E vector at 2, 0, 0. So that's why we are going to find out the angle from this point 2, 0, 0. We because we are having the point P, so that projection is on the z axis, but we are having the projected point itself in our problem, because this projected point is on the axis, because we are having 2 comma 0 comma 0, but we don't have any of the point on the xz plane or yz plane or xy plane. We don't have such points. We are having a point. We need to find out the point where this point is on the axis itself. So we don't have to find out. We don't have work to find out projection, but we are having the real point itself on the x-axis. அதாவது ரியல் பாயிண்டே நம்மகிட்ட இருக்கு, ப்ரொஜெக்ஷன் ஒன்று தனியாக கண்டுபிடிக்க தேவையில்லை, அதான் இங்கே வந்து நம்ம சொல்ல வரோம். So we need to find out the angle. So the angle of this particular A, the angle from this particular point to A is called as alpha 1, and to B it is alpha 2. Also you can find out this particular projections also. So this angle is alpha 1, this angle is alpha 2. You have to notice one thing: the direction of angle measurement from if you are going to take this as a reference line, you are going to measure angle from this line to the counterclockwise direction. That is this is going along the counterclockwise direction, but here for this angles alpha 1 alpha 2 you have to go for the clockwise direction. So if you want to find out this particular angles, then these angles are positive, then these angles are going to be negative angles. So these two things you have to keep in mind. So if this is clear, then we can go for the problem. We are having the electric field intensity formula as we have seen in the slide. We are having that same formula here. We need to find out what is rho here. Rho has been given 20 nanocoulomb per meter. You have to find out what is rho is. So how to find out rho? Because rho is the point where this particular P point x, y, z. So you have to find out what is root of x square plus y square is the rho. So we have defined this parameter in the derivation itself. So we are going to take that particular point only. So rho is equal to root of x square plus y square. So how to find out this rho? We are having that point as 2 comma 0 comma 0. So x is equal to 2, y is equal to 0. So we will be having rho as rho is equal to root of 2 square, which is equal to 2. The point at which the E vector to be found out is 2 comma 0 comma 0, and z is the segment 1 is from plus 5 to plus infinity, segment 2 is minus 5 to minus infinity. So E vector due to this segment 1 can be found out as such like this. Just notice this diagram. Alpha 1 is this particular triangle. This triangle is going to be the alpha 1. So what is tan alpha 1? Tan alpha 1 is opposite side divided by adjacent side. So what is opposite side? Opposite side is a 5. What is adjacent side? It is 2. So tan alpha 1 is equal to 5 by 2. Why we are finding out this tan alpha 1? We need to find out what is alpha 1 is. So we are having a particular real number over here. So we can find out what is tan alpha 1 from this particular depiction. So you are going to take this triangle. You are going to find out what is tan alpha 1. Tan alpha 1 is opposite side by adjacent side. Opposite side is 5, adjacent side is 2. So tan alpha 1 is equal to 5 by 2. So if you want to find out what is alpha 1, take tan inverse. Tan inverse of 5 by 2 is 68.1986 degrees. What is alpha 2? Alpha 2 is going to be pi by 2. Why we are having the pi by 2? Because if this particular edge is going to be infinity, then this angle is going to be pi by 2. Why? Because we have depicted in the derivation itself. If we are having 0, 0, infinity, means the angle is going to be alpha 1 is equal to pi by 2. Why? Because if the b vector is going to be at the infinity, means then this alpha 1 is going to be infinity only, because we are going to have this particular line on the minus infinity axis. So the angle between this projection to this point will be at the minus infinity. So that is going to be pi by 2. And if this b point is going to be at the plus infinity, then this alpha 2 will also be going to be at the minus pi by 2, because we are measuring from clockwise direction. That's why we are having the minus pi by 2. So the same convention is going to be used here. So we will be having the alpha 2 as pi by 2, as we have given in the previous derivation itself. So if you substituting these values in this particular equation, so rho L is 20 nanocoulomb. So 20 into 10 power minus 9 into 9 into 10 power 9, because we are having 1 divided by 4 pi epsilon naught. So that is going to be 9 into 10 power 9 divided by this rho. Rho is 2. You know, so 2 into sine alpha 2 is pi by 2. So sine 90 minus sine 68.1986 of a row vector plus cos of 68.196 minus cos alpha 2 is cos pi by 2. So cos pi by 2. So what is sine pi by 2? It is 1 minus sine of 68.196 is 0.9285, and cos this value is 0.3714 minus cos pi by 2 is 0. So if you estimate, then E1 is equal to 6.435 aero cap plus 33.426 EZ vector. What is the E vector due to the segment 2? Segment 2 will also be the tan alpha 1 is equal to 5 by 2 only, because we are having this particular triangle. So we are going to have minus 5 2. So we will be having this particular angle difference. So 5 by 2. So the alpha 1 is going to be 180 minus tan alpha tan inverse of 5 by 2. So if you estimate, the value will be 111.8014. That is alpha 2. It is 180 minus pi by 2, which is also going to be pi by 2. So if you substitute the rho s value 20 nanocoulomb, so 20 into 10 power minus 9 into 9 into 10 power 9 divided by 2 sin pi by 2 minus sin 111.8014 aero cap plus cos 111.8019 minus cos pi by 2. So if you put the values, then you will be getting this answer. You are going to add these two values, then this vector and this z vector is going to be cutted out. So you will be having only the aero vector, which is equal to 12.87 value of aero cap. Thank you.